Okay, so what it's asking for is the, I don't ever know how to say this word.
Thevenin?
Thevenin resistance.
It's like Yerevan, which is capital for me.
And Thevenin voltage and the Norton equivalents. So to find the, first thing you want to find is the Thevenin equivalent. And what you do to find that is you do it just like we found the regular total resistance, except you work from, like, you act like the battery's here and there's nothing here, so you work backwards from here. So this is in series with these two in parallel. Does that make sense? So we're going to find R12 first, and that's going to be, so 1 over R12 equals 1 over 12 ohms plus 1 over 20 ohms. And what's R12 equal to when you do that? You get it, Rachel?
7.5.
For once, I'm
So-
not doing
sorry.
all that you got.
7.5 ohms. So now we just do 7.5 plus 11 for our REQ. It's going to be 11 ohms plus 7.5 ohms, and REQ equals 18.5 ohms. So does that make sense how to find the, it's called the Thevenin equivalent resistance.
Wait, REQ is Thevenin?
The REQ is just the equivalent resistance. We found here is the Thevenin equivalent resistance for these 2 points.
For A and
So
B.
when
For A and B.
finding the resistance, you just assume that the second one's in, or R2 is in parallel?
Well, what you're assuming is that, like, the circuit goes from here to here, so from A to B,
Okay.
and so you ignore the battery. So what this is saying is if we hooked up, like, something that was measuring resistors at these 2 points, that's what it would give us.
Okay.
Does that make sense? Okay, so now I'm going to erase this, if I can find an eraser. Actually, I need to keep that.
What does it accomplish? Like, what do we use it to find? Like,
What you're finding is what is happening at these 2 points. So, like, if you were like, if you want to, you can make a circuit that has a certain voltage or certain resistance when things are connected to these 2 points.
Okay.
Does that make sense?
So for resistance, so the Thevenin equivalent is the resistance, and then the, I'm assuming Norton would be voltage then?
Well, Thevenin equivalent is the voltage and the resistance, is what we refer to as Thevenin. The Norton is the current that would be across
Oh,
those
okay.
2
So
points.
we're not done. We only have half of Thevenin.
We only have half of Thevenin.
Okay.
Okay, so to find the voltage, what do you think is going to be equal to the voltage drop across these 2? Is the voltage drop across one of the resistors? Which one?
Across one of the resistors?
Yeah.
Probably. Let's go with R220.
R220 is right. So the voltage drop across R20 is equal to the voltage drop from A to B. Does
Okay.
that kind of make sense? So to find the voltage drop across R20, we're going to find the total current in just this part of the circuit. So this is the actual circuit that's working. Nothing's going through here because these 2 aren't connected. So we're going to just use that series circuit right there, find the total current in that circuit, find the voltage drop across R20.
Okay.
That's the equivalent voltage.
So those 2 are just in series then? So,
Yep.
Okay, so this.
So RT is going to equal 32 ohms. What's the total current the circuit going to equal?
24 over 32, which is 0.75.
Amps, and then we want to find the voltage through R2, so we're going to call that V2, and that's equal to the equivalent voltage from A to B, and that's going to be 0.75 amps times 20 ohms, so V EQ equals 15 volts. So that's the voltage drop from A to B is 15 volts. Does that make sense to everybody?
Yep. So it's going to be posted online somewhere?
It's going to be posted online somewhere.
Sounds listening to parts.
Okay.
It does that anyway.
Now, the Norton equivalent is actually really, really easy to find once you have these 2. So the Norton equivalent is usually
It's just,
IEQ, and it's V equals IR.
yeah, that's what I figured.
So it's going to be VEQ over REQ. So we can say VEQ equals IEQ times REQ. And so we get 15 volts over 18.5 ohms equals 0.8 something maybe.
0.81.
So our equivalent current is 0.811 amps. Does that kind of make sense to everybody?
Yep.
Alright, I'm gonna stop the video.
And then there's just another example. That's pretty